These notes are going to cover angle bisectors. Let's start with the theorem. It says if a point is on a bisector of an angle, then the point is equidistant from the sides of the angles. So here's our angle, BAC, and it says AD, this segment here, or this ray, bisects the angle. That means each of these angles, these smaller angles, are going to be congruent. And AB is perpendicular to BD, and AC is perpendicular to CD, well then BD is going to be congruent to DC. This segment is going to be congruent to this segment here. The converse of the angle bisector theorem states that if a point is on the interior of an angle and equidistant from the sides of the angle, then the point's on the angle bisector. So this time we're going to start with stating the segments are congruent, BD congruent to DC, and AB perpendicular to BD, AC is perpendicular to CD, well then AD is going to bisect angle BAC, and the angles are going to be congruent. So angle BAD is going to be congruent to angle CAD. Let's take a look at an example. So what we see here, we'll be applying the angle bisector theorem. So the two little segments, these guys, will be congruent to each other. Let's go ahead and set those equal to each other and then solve for x. All right, let's get our x's on one side. So I'm going to take away 4x on both sides, and I'm going to go ahead and add 5 to both sides. So I have 35 is equal to 5x. Divide both sides by 5, and x is equal to 7. In problem number 2, we'll use the converse of the angle bisector theorem, which states that the angles are going to be congruent to each other. And so we can set those angles equal to each other and then solve. All right, subtract your 5x to both sides and add your 41 to both sides. So we end up with 30 is equal to, what is that, 3x, and x is equal to 10 when you divide. All right, problem number 3, again, we've got congruent segments. So we have 13x minus 4 is equal to 8x plus 11. Take away 8x on both sides and add 4 to both sides to combine our like terms. Let's see, this gives me 5x and 15, so x is 3. But the question's asking me to find AD. We'll need to go ahead and substitute in the 3 for the x. So 13 times 3 is 39, minus 4, and we get 35. In problem number 4, we're trying to find the measure of angle XWZ. So XWZ, this guy right here. Let's go ahead and set our angles congruent to each other. And then let's solve for x. We end up with 5x is equal to 35, and so x is equal to 7. If I substitute in my 7 for the x, I have 8 times 7 minus 32. So what is that? 56 minus 32, and we get 24. And that is degrees because we're talking about the angle. In problem number 5, we're looking for the measure of angle FGH. All right, same thing here. We've got some congruent angles. So we'll set these expressions equal to each other and solve. Subtract the 2x on both sides and add 37 to both sides. So we have 57 is equal to 3x. If I divide both sides by 3, x is going to give me 19. If I want to find the measure of that angle, FGH, that is this big angle here. Let's go ahead and we can sub it in for either of the x values. So I'll go ahead and just plug it into this first one. 2 times 19 plus 20, that's 38 plus 20 is 58. But that's just this angle here. I need to go ahead and double it to find the bigger angle. So if I multiply by 2, 2 times 8 is 16, carry the 1, that's 10, 11. How about 116 degrees? And the last problem, we want to find QR, this piece right here. We know that these segments are going to be congruent to each other, so let's set them equal. and solve for x. And we have 2x is equal to 32, where x is equal to 16. If I want to find the segment from Q to R, I'll plug in the 16 in for the x. And let's see, what's 5 times 16? Let's do a little bit of multiplication. So let's see, it's 30. How about 80 minus 8, and we get 72. QR is equal to 72.